Hello students, today we will be discussing the quick solutions of All India Akash Test Series JEE Advanced Paper Test 6A Paper 2 which was held on 28th April 2019. So let us start with the question number 41 which says that if A, B and C by 4 are in AP and taking ABC as parameters, the slope of the member of family of lines AX plus BY plus C equal to 0 which is normal to the parabola y square equal to 16x is. Now we know that if three numbers are in AP, then we can say that 2b is equal to a plus c by 4, that is 4a minus 8b plus c is equal to 0, as it have been given that the family of lines is ax plus by plus c equal to 0. It means that the family of lines are passing through the point 4 comma minus 8, right? Now it can be observed that this point is lying on the parabola y square equal to 16x, right? So we just have to find the slope of the normal passing through the point 4 comma minus 8. Now differentiating y square equal to 16x, we will get 2y into y dash equal to 16, that is y dash is equal to 8 upon y. So this is the slope of tangent. So slope of normal will be equal to minus y upon 8. Now when y is minus 8, then the slope will be 1. So we can say that the slope of the member of family of lines which is normal to the parabola y square equal to 16x is 1. So its answer will be 1. Next is question number 42, in which we have to find the limit x tending to 0 sin 4x plus cos 8x whole raised to the power cot 2x, right? We have to take its greatest integer. So let us firstly see that this limit is of the form 1 raised to the power infinity form. So let us take L is equal to limit x tending to 0 sin 4x plus cos 8x whole raised to the power 1 upon tan 2x. Now as it is of the form 1 raised to the power infinity, so we can write it equal to e raised to the power limit x tending to 0. In the denominator we will have tan 2x and here it will be sin 4x plus cos 8x minus 1. Now if x is tending to 0, then it can be seen that it is of the form 0 by 0 form. So we can apply L'Hopital. So this will be equal to e raised to the power limit x tending to 0 differentiation of sin 4x, that is 4 times cos 4x minus 8 times sin 8x divided by 2 times secant square 2x. Now for x tending to 0, it will be 4 divided by 2. So that is equal to e square. Now we have to find the greatest integer of e square, that will be equal to 7. So answer of this question will be 7. Next, let's discuss question number 43 now, which says that if alpha comma beta are the roots of the equation x square minus 2x minus 1 equal to 0, then we have to find the value of this term. Now as alpha and beta are the roots of this equation, so we can say that alpha and beta will satisfy it, that is alpha square minus 2 alpha minus 1 will be equal to 0 and beta square minus 2 beta minus 1 will be equal to 0. Also we can say that the sum of roots, that is alpha plus beta, will be equal to 2 and product of roots, that is alpha into beta, will be equal to minus 1, right? So now we have to find the value of alpha upon alpha cube minus 2 alpha square plus 1 plus beta upon beta cube minus 2 beta square plus 1. Here in the denominator, if we take alpha common, so we will get alpha square minus 2 alpha, that is from equation 1 it can be written equal to 1. So that will be alpha plus 1. Similarly here also we take beta common, so we are left with beta square minus 2 beta, that from equation 2 can be put equal to 1. plus 1. So this is equal to alpha upon alpha plus 1 plus beta upon beta plus 1. So taking LCM, this is equal to alpha plus 1 into beta plus 1, and in the numerator we have alpha plus beta plus 2 times alpha beta. So that will be equal to 2 minus 2. So that is equal to 0. So the answer of this question will be 0. Next is question number 44, which says that the number of integral values of x satisfying the equation greatest integer of sin x into greatest integer of cos x equal to greatest integer of sin x into cos x, where x is going from 0 to 2 pi. Now let's find the value of sin x into cos x GIF, and here let's find the value of greatest integer of sin x into cos x. So let us take different cases here, that is x equal to 0, x belonging from 0 to pi by 2, x belonging from pi by 2 to pi, next x belonging from pi to 3 pi by 2, and next is when x belongs from 3 pi by 2 to 2 pi. As we have to find the integral values of x, so let's not find the values at x equal to pi by 2, pi, 3 pi by 2 and so on, right? Now for x equal to 0, the value of this will be 0 and this will also be 0, right? Now for x going from 0 to pi by 2, again here the value will be 0 and here also it will be 0, right? Now for x going from pi by 2 to pi, then here value will be 0 and here it will be minus 1. Why? Because this is nothing but greatest integer of sin 2x upon 2. Now for x going from pi to 3 pi by 2, the value will be minus 1 into minus 1, that is 1 here and 0 here. And for x going from 3 pi by 2 to 2 pi, the value will be 0 here and here it will be minus 1. So we can see that only in these two intervals the values are equal. So we can say that the integral values of x are 0 or 1. Hence there are two such values. So the answer is 2. Next is question number 45, which says that the number of values of x lying in the interval 0 to 2 pi such that sin x, tan x and cos x are in GP. Now we know the condition for GP, that is tan square x should be equal to sin x into cos x. So converting the function into sin x and cos x, we will get sin square x minus sin x cos cube x is equal to 0. That is, taking sin x common, we get sin x minus cos cube x is equal to 0. That is, either sin x is equal to 0 or sin x is equal to cos cube x. Now sin x cannot be equal to 0, because if sin x is 0, then all these terms will become 0. So it will not be a GP. Now this condition is only left here. Now for finding the solution of this, let's plot the diagram of sin x and cos cube x. So from 0 to 2 pi, this is the graph of sin x. And we know the graph of cos x, that is something like this. So the graph of cos cube x, that will be something like this, right? Now here we can find the points of intersection of sin x and cos cube x, that is 2 points, right? So we can say that the number of values of x lying in the interval such that these are in GP is 2. Now next is question number 46, which says that consider the function fx. So we have to find the value of f101. So firstly, let us use binomial theorem to expand the function. So that is, fx is equal to multiplying in the numerator and denominator by x raised to the power 10. So we will get x raised to the power 4 plus 1 whole raised to the power 5 minus x raised to the power 20 plus 1 upon x raised to the power 4 into, providing x raised to the power 6 inside the bracket. So we will get x raised to the power 4 plus 1 whole cube minus x raised to the power 8 plus x raised to the power 4. Now expanding this by binomial theorem, we will get it equal to 1 plus 5c1 into x raised to the power 4, that is 5 into x raised to the power 4, plus 5c2, that is 10 into x raised to the power 8, plus 5c3, that is again 10 times x raised to the power 12, plus 5c4, that is 5 into x raised to the power 16, plus 5c5, that is 1 into x raised to the power 20, minus x raised to the power 20 minus 1. And in the denominator we have x raised to the power 4 into 1 plus 3x4 plus 3c2, that is again 3x raised to the power 8 plus x raised to the power 12 minus x raised to the power 8 minus x raised to the power 4. Now here it can be seen that these values will get cancelled. So this can be written equal to, taking 5 common, x raised to the power 4 plus 2 times x raised to the power 8 plus 2 times x raised to the power 12 plus x raised to the power 16 divided by x raised to the power 4 multiplied with 1 plus 2 times x raised to the power 4 plus 2 times x raised to the power 8 plus x raised to the power 12. So if we take x raised to the power 4 common in the numerator, we will be left with 1 plus 2 times x raised to the power 4 plus 2 times x raised to the power 8 plus x raised to the power 12. That is written in the denominator also. So those two will get cancelled and x raised to the power 4 will also get cancelled. So this will be equal to 5. So the value of f101 will also be equal to 5 because it is a constant function. So its answer will be 5. Next is question number 47, which says that let f of n comma theta is equal to 1 plus e raised to the power iota theta and so on up to n terms. Then we have to find the value of this one, right? So here f of n comma theta can be written equal to, if I divide and multiply with 1 minus e raised to the power iota theta, then we will get, as we have n terms, here it will be up to, so as we have n terms, so it will be 1 minus e raised to the power iota times 2 raised to the power n into theta. So that is equal to 1 minus cos 2 raised to the power n theta minus iota into sine 2 raised to the power n theta, and in the denominator I have 1 minus cos theta minus iota into sine theta. As we know that 1 minus cos 2 theta is equal to 2 times sine square theta. So we can write it as 2 times sine square 2 raised to the power n minus 1 theta minus sine 2 theta is equal to 2 times cos theta into sine theta. So I can write it as minus iota into 2 times sine 2 raised to the power n minus 1 theta into cos of 2 raised to the power n minus 1 theta, and in the denominator we have similarly 2 times sine square theta by 2 minus 2 times iota into sine theta by 2 into cos theta by 2. Now next, here it can be seen that these 2's will get cancelled and we can take common sine of 2 raised to the power n minus 1 theta, and in denominator also sine theta by 2. Also, if we take minus iota common from the numerator and denominator, then they both will get cancelled and we will be left with cos 2 raised to the power n minus 1 theta plus iota into sine of 2 raised to the power n minus 1 theta. So we can directly write it as e raised to the power iota into 2 raised to the power n minus 1 theta, and the denominator we will have e raised to the power iota into theta by 2. So this is equal to sine 2 raised to the power n minus 1 theta upon sine theta by 2 multiplied with e raised to the power iota theta into 2 raised to the power n minus 1 minus 1 by 2. So we have to find the value of f of 8 comma pi upon 256. So putting value of n equal to 8, we will get sine 2 raised to the power 7 into theta upon sine theta by 2, that is pi upon 512 into e raised to the power iota theta into 2 raised to the power 7, that is 128 minus 1 by 2. So solving this, we will get it equal to, as the value of sine of 2 raised to the power 7 theta will be 1, so this is equal to 1 upon sine pi upon 512 into cos of 128 minus half into theta pi into 1 by 2 minus 1 upon 512. This will be the value of real part of f of 8 comma pi upon 256, whose value will be equal to 1, right? So putting it here, we can find that 5 minus 2 into 1, that is equal to 3. So the answer of this question will be 3. Next is question number 48, which says that the maximum value of the expression under root of this one for alpha comma beta belonging to R is, right? Let us assume the quantity inside the under root as f of alpha comma beta. So this is equal to 9 cos square alpha plus 5 cos square beta minus 14 cos alpha cos beta minus 16 into cos of alpha minus beta can be written as minus 16 cos alpha cos beta minus 16 times sin alpha sin beta plus 20. Let this value be equal to f of alpha comma beta. So this is equal to 9 cos square alpha plus 5 cos square beta minus 14 minus 16, that is minus 30 cos alpha cos beta minus 16 times sin alpha sin beta plus 20 can be written as 16 plus 4, and 16 can further be written as 16 cos square alpha plus 16 sin square alpha, right? Plus 4 can be written as 4 cos square beta plus 4 sin square beta. See, let's see what we'll get from here. See, this can be written equal to 4 sin alpha minus 2 times sin beta whole square, right? We have used this one plus this one and this one. Similarly, using the others, we can write it as 5 cos alpha minus 3 cos beta whole square, that is 25 cos square alpha, that is from here, and 9 cos square beta from these ones, and minus 30 cos alpha cos beta. So this can be written as this one. Now we want the maximum value of this expression. Now what does this mean? This means that distance between the points 4 sin alpha comma 5 cos alpha and 2 sin beta comma 3 cos beta. This is nothing but distance between these 2 points. Now these 2 points are nothing but ellipse, that is this ellipse is x square upon 16 plus y square upon 25 equal to 1, and this is the ellipse x square upon 4 plus y square upon 9 equal to 1. So we just have to find the minimum distance between these two ellipses. That is this one ellipse where this is 4 and this is 5, and the other ellipse where this is 2 and this is 3. So this will be the maximum distance. So its value will be equal to 5 plus 3, that is 8. So answer of this question will be 8.